All right, gentlemen, back again. We're still doing the speed of light. Let's do a few more of these practice questions. Question number 4. In a Michelson-like experiment, a 6-sided mirror is rotating with a period of 355 microseconds. If the measured speed of light was 3.2 times 10 to the 8 meters per second, then find the distance between the mirrors in kilometers. So our basic equation. Okay. What we'll do is we're going to solve it for d. Now notice this, right? You want to have the 1 over n. You can multiply both sides by 1 over n. You can multiply both sides by t, and you can divide by 2. So to solve this for d, you've got v times t over n times 2, or 2n. Let's put in our values here. So we have the measured speed of light, which is 3.2 e8, the time period, 355 microseconds. Divide that by 2 times 6. And the calculation. Okay. All right, I get 9,466.6 repeat, so to 2 significant digits, we've got 9.5 kilometers. Question number 5. A radio tower sends out a signal at an angle of 41 degrees above the horizontal. The signal reflects off of a plane and returns to the transmitter in a total time of 7.5 microseconds. Determine the height of the plane. Okay, so what we need to do is we need to look at the distance that it is away. So I'm going to label it here for a distance. Okay? So I'm going to find that using the time interval and the speed of light. So what I have here is d equals c times t. So I have 3 e8 for the speed of light. Now the time period is half of 7.5. Okay? So it'd be 3.75 e negative 6. So figure that out first. All right, 1,125 meters. Now for the height of the plane, we want to use some trigonometry. We're looking for the opposite side to the angle, and we have the hypotenuse, so we're going to work with sine. Sine of 41 degrees is equal to opposite, which is the h I'm looking for, over 1125. Okay, so 1125 times the sine 41. 738. Question number 6. In a Michelson experiment, the two mirrors are located 4.7 kilometers apart. If the speed of light was measured at 2.9 times 10 to the 8 meters per second, then at what frequency is the 8-sided mirror rotating? All right, when we look at the equation here, just to kind of maybe tidy things up a little bit, or maybe a different way to look at it. This equation, of course, since t is equal to 1 over f, and this numerator divided by 1 over n is really just, n belongs as multiplied on the numerator. We can write the following equation. Okay? So, in other words, 1 over n is equal to n. I can write it as v equals 2 d n f. Now we're just going to go ahead and solve this one here for the frequency. Frequency is going to be v over 2 d n. I'm going to put in 2.9 e8 and 2 times 4.7, and the mirror is an 8-sided mirror. It's pretty dark in here. 3856.4. And so what do we have here for an answer here? 3.9 times 10 to the third hertz. Okay, I'll stop it right there and see if we can pay our power bill.